Part10, and we are discussing here my interpreted Milne model. I've been clear in my post that I disagree with some aspects of Milne's model, um, and he has seen YouTube posts with stage explosions, and I've been working on variations, and that is clear to him. And this is interesting. Both George and Jonathan have stated that the special relativity has so much contraction you can pack an infinite number of particles into a finite volume. And this And I think I actually believe this. So I I absolutely think this is true. That you especially in the Milne model, I think George and a lot of other people will pay lip service to this. But I don't feel like they've really got. I don't feel like his. And that's the thing. Avowal of advocacy not backed up by deeds. George George doesn't seem to have a. I feel like George doesn't believe the Milne's model is correct because he kind of says that SR has so much length contraction you can pack an infinite number of particles in a finite volume, but he does not follow that up by. Um, okay, so he says this reminds me of that philosopher who told an archer in Greece that his arrow could not reach him because it first had to cover half the distance, then from the rest again half the distance, and so on. The response from the archer was, "What about trying if you are right?" And my feeling is, yeah, I, I'll, I mean, if you have something where things are based on length contraction, I would probably run an experiment first before I jump in front of the arrow. But once the experiment is done, I don't want any calibration errors. Goodness. But the arrow, it would be interesting to try to come up with some kind of test because that you at least a hypothetical one. Like I would definitely be one to say, yeah, sure, why not? As far as this idea, I don't feel like uh, yeah, that avowal of advocacy. I I think I do have that, whereas I don't feel like others have that. You know what? Let me show you the difference between these the two levels of advocacy here. So here are two different presentations of the Lorentz transformation. Hope it records okay. It seems to. All right, the one on the left shows a finite Lorentz transformation, stopping, then turning back. And the one below shows an infinite Lorentz transformation, continuing to accelerate forever. Accelerate to the right forever. What about Planck's constant? Planck's constant, I believe, is h equals 6.63 times 10 to the negative 34th kilogram meters squared per second. Well, Planck's constant seems to be very accurate as far as it comes to the photon energy of light. This works really well, that the energy of a photon is equal to the Planck's constant times its frequency. Now, Planck length, I know I consider it to be what's a word for it? Well, it's essentially without merit. It's a game to see if any. It's basically a game to see if you have any brains at all in your head. or if you have any idea what you're talking about. Planck mass, I'm not sure what the Planck mass is, but the Planck length is something about the Schwarzschild radius of a given mass. I'm going to have to look up that one. Wavelength of a photon with a given energy. We're going to say E equals hc over lambda, and lambda, so lambda equals hc over E, and then pretend that radiant energy has a mass associated with it, which it does not, and plug that in there. So h over mz, and so that's our lambda, and then we're going to figure out the Schwarzschild radius of a given mass. So the Schwarzschild radius of a given mass is given by that equation there. So you can put these two things together to get, basically we're going to take that Schwarzschild radius and set it equal to that wavelength. Or actually we're going to say that wavelength cannot be less, lambda cannot be less than r sub s. Because if it was shorter than r sub s, then that photon would have the radiant energy big enough to create a black hole, which is nonsense, but we're just going to go ahead and plug in the numbers anyway, even though h over mc equals 2gm over c squared. You know what? Actually, I think I'm supposed to solve both of these for the mass, and then set those two things equal, and that'll give me an equation related to the wavelength and the r sub s. So over here, m equals r sub s over 2gm over 2g times c squared, right? And over here, m equals h over lambda c. So setting those two things equal, we will have r sub s c squared over 2g equals h over lambda c, and we will get r sub s times lambda equals h over c cubed times 2g. What's that come out to be? Let's see, that comes out to be 2 times 6.63 times 10 to the negative 34th kilogram meters squared per second times 6.67 times 10 to the negative 7th kilogram meter squared per, what is it? It's Newton meters squared per kilogram squared. And then on the bottom, we'll have 3 times 10 to the 8th cubed. Now, the problem is, I'm not sure how this is going to come across. R sub s lambda is going to end up having two things in it. So I feel like this came out differently than it did last time I tried it. Anyway, this comes out to be 3.28 times 10 to the negative times 10 to the negative 69th. And let's do units. Kilogram meters to the 2, 3, 4 meters to the 4th divided by kilogram squared seconds times seconds cubed per meter cubed times newtons. So Newton is kilogram meters per second squared. So 1, 2, 3, 4, 5 meters on the top, 3 meters on the bottom. So this is going to be 3.28 times 10 to the negative 69 meters squared. And then we'll have kilograms, kilograms, kilograms squared. That cancels out. Meters cubed, we already did those. Seconds cubed, seconds. So this is good. R sub s lambda equals this, and then we'll just take the square root of that, and I ended up with 5.72. Square root of r sub s times lambda is 5.72 times 10 to the negative 35th. So that is on the same order of magnitude, 1.6 times 10 to the negative 35th, I just looked it up, is the Planck length. Let's just divide this by pi, and then actually that gives me 1.8. I have no idea why I would divide it by pi. Let's check and see if see what they've got in Wikipedia about this part of it, because I've got 2hg over c cubed. Okay, this is what Wikipedia has for Planck length. It is square root of h bar g over c cubed. H bar, which would be equal to square root h over 2 pi times g over c cubed. So, that's interesting. I wonder where I went wrong, because I feel like that's not going to come out the same as what I got. Well, it certainly didn't come out the same, but this comes out to be 1.6 times 10 to the negative and 10 to the negative 35th. And this comes out to be, what was it? 5.72 times 10 to the negative 35th, negative 69th. No, that's not right. Yeah, came out to be this number here, which, wait, no, yeah, this one's squared. Be this squared. Anyway, maybe they decided to take, instead of taking the entire wavelength of the function, they're probably thinking along the lines of, like, instead of taking the entire wavelength of the function, which would go from there to there, they're just kind of some part of it, some part of the function, which would be right here, lambda over 2 pi or something like that, just one radian of the wavelength. Maybe it is a sinc function or something like that. I don't know exactly how big of a sinc. They're just, so that's probably essentially what they did. Or maybe they're even, okay, did I end up with a 2? Yeah, I ended up with a 2. Where did the 2 come from? From right there. So the 2, maybe they're even constraining it even more than that, saying this is lambda over 4 pi and just taking it very tight of the wavelength. But the biggest problem with it is that they're assigning a mass to a radiant energy and acting like that mass is going to result in a black hole, and it just is not going to do that. Sorry, I don't know anything about the Planck mass off the top of my head. It might be what mass I was about to solve for here. That could be. Again, we'd probably want to put h bar and h bar over 2 or something like that in there. But yeah, Planck length is not definitely out as far as my theory goes. Planck length